Welcome back to 100% Epic. I'm Chris. Today is part 2 of the Mullet mod for the Tiny Whoop. Now if you didn't watch part 1, that's where we modified the VTX for a low profile. In this episode what we're going to be doing is covering the vacuum forming of the new lid or canopy for the Tiny Whoop, and it's something you can do home, so definitely stay tuned. Let's first talk about vacuum forming from a manufacturing standpoint so you better understand the process as we move forward. Essentially, vacuum forming takes a thermoplastic such as a polypropylene, a Lexan, or in this case a polystyrene. We heat that sheet up until it becomes malleable and flexible, and we use vacuum to draw it over a buck or a blank or a mold. Now, when I first started in vacuum forming, I actually had to CNC these molds out. And once you CNC'd them, you had to prep them with resin, sand them, polish them, paint them, prime them, and then wax them. And you can see the various stages here. And then you'd finally end up with something you could vacuum form, trim it out. And in this case, this is the lower arm to an F450 quad when I was vacuum forming body shells, when people were flying F450s around. Now this is a very large commercial vacuum forming machine capable of doing RC car bodies, and this is a smaller one capable of doing smaller things like dental work and all that other stuff, as well as modeling things such as this. Now you don't need any of this, especially for something as small as this, and none of this process is relevant now with 3D printers. You're actually able to 3D print out a small form like this, or a buck or a mold. It has to be designed properly for vacuum forming, and I'll go over some of those aspects when we jump to the computer. And then you can just vacuum form this just like I started vacuum forming, actually in the B17 behind me, using the shoebox vacuum cleaner and hair dryer method. And all the parts on that B17, the engine cowls and things like that, were all vacuum formed using that exact process. Let's go ahead and jump to the computer, and I'll first explain the way that you've got to design your part for vacuum forming.
Hey, welcome to the computer side of things. I'm going to talk about how and why I made this, so you guys can definitely design and make your own using your CAD software. First thing I've got down here is just a basic extrusion, and I've actually achieved this if I come right over here to sketch and click it on by creating circles right over here, measured off on that, and then I just trimmed back from the square that I used to create the points and the circles, and it left me with this little X pattern right in here, which fits the nacelles. From there, I took the extrusion, I extruded it up from the height I measured to clear the camera itself. Next, I drew a sketch line along the side of it, I believe this side, and used that to do an extrude cut right along here to get my profile where my camera is. And I was using reference geometry. I actually drew the camera internally in here using the X-ray. You can see it, and the camera's right in here, but I created a side cut profile like that, and then just keep doing a cut. I came along the other side and did the same thing, and then I used this plane to mirror it to the other side. And from there, I've got the general basic shape of what I wanted. I just cleaned this up by just doing a couple of fillets. Let's see how we smooth it out. Put it some on the front, and then just one on to the back side. And so we ended up with a really nice smooth cap. Go ahead and turn these lines on so you can kind of see the general makeup of this. Took maybe about 10-15 minutes, fairly quick and easy. But if you got that general reference sketch with this here, there's no reason you couldn't make anything you wanted just using extrusion cuts and filleting this thing. Now from the top side of things, I actually want to change on my next one and create more of a ellipse, or a little bit smoother right in this area where it arcs back and more teardroppy. But this will work for right now. Now when you're designing this mold, remember we're going to be vacuum forming it. So I'm going to go ahead and just kind of look at it from the side here. And if you look, there's nothing that overhangs this way, like when you're 3D printing where you have an overhang in you and need supports. You can't do that when you're vacuum forming, because what would happen, looking at my mouse, is the plastic will come down and then it would suck up underneath, which means that you could never remove this mold from the vacuum forming. You'd have to cut it out and create slits, or you'd have to create a mold that was a multi-part, so you pulled out a center and it allowed the sides to collapse in and then out the bottom of that. So you can do undercuts, but then it's a real complex mold. Here we just wanted a simple straight, so everything is working with what's called a positive giraffe. Now the next thing that we're going to look at is how high this mold is. because we're going to have a cut line that's going to come along here, it'll cut down along here, and then cut up right in here. We want it longer than we need necessary, and I'll explain why that is in the vacuum forming, but essentially we're going to have a little bit of a fillet as the plastic comes up close. It's going to cool and stretch, and we're going to have a little bit of curve right here. So if we take a look at the original, this white right here is actually the vacuum formed original, and here's the mold, and you can see how much taller it is than we actually need. You want to go ahead and design that in your mold, so keep a positive draft, so nothing that goes underneath it, as well as give yourself extra height because you're going to need a cut line. So when you design the part, don't design it to look like that, because remember, if you try to vacuum form that won't work. So you have to take everything that's overhanging and go straight down with it, and you're going to have to come back and trim that out afterwards, and so you're going to end up with that. So this is a real quick drawing that I made, and then from here I just took this right into my 3D printer and printed it off, and we'll jump over to that. Okay, so I exported the model and just brought it into my slicing program for my 3D printer. From there, just prepared to print it, and like I said, I printed this actually at a fairly low resolution just to get the feel of the vacuum forming with a 3D print. And you can see it only took 21 minutes on this one, and of course I would recommend a higher resolution print so you don't see the lines. Vacuum forming pulls a lot of really high resolution detail, and you can actually see the layers. So I'd recommend doing a real high res print on this one. But you can see 21 minutes, it's no overhangs, and then just goes straight up and over. Fairly small print, so any small printer will be able to handle this, and the time involved in making these molds is absolutely nothing on it. So definitely explore and make your own.
Okay, now that you have your 3D printed mold, let's go ahead and get started with the vacuum forming process. What you're going to need is a hobby box or a shoe box that has a larger width on top than the hoop itself. I'm using a 6-inch sewing hoop, but these are about $1 at the craft store, just a bamboo hoop, and it's appropriately sized for our particular mold. You're going to need to get some thermoplastics. You can just buy them in sheets, and you can see that's going to fit in a hoop quite well. You're going to want to start off around 0.4 millimeter thickness, and you can vary this depending on how much heat you're using, going thicker or thinner. Remember, as it comes around the mold, it's going to be stretching it, so it's going to get thinner. So you want to start off with a little bit thicker plastic. There's also some tricks that I'm going to talk about that you can do while you're doing the vacuum forming process to create a thinner, lighter part, or create the opposite of thicker areas or stronger in certain areas. The other thing you're going to need is just a little petroleum jelly. We're going to use this as our mold release. You're going to need some tape just to seal up the box around the sides, and some double stip tape to put hold the mold on down. Let's go ahead and start. All right, first thing we're going to do is go ahead and prep our box. What we're going to need to do is just take our sewing hoop, place it right into the middle, trace on the inside to create a line inside there, and then take our mold, place it right into the center, and do the same thing, trace around the inside of that. And this is going to give us an outline on the box where we're going to be able to start poking some holes right in here. The reason we need holes into this box is we're going to cut a hole right into the front of the box, and that's where we're going to put in our vacuum cleaner hose. It's going to draw the vacuum through the top, and when we put our hoop with the plastic on it and push it down over it, the vacuum through these holes is going to draw down through and out towards the vacuum cleaner, so it's going to use it to draw it on down. But when we lay down these holes into the top of the box, there is a little bit of science behind that. So let's go ahead and go over that real quick. All right, so the drawing on top of your box should look similar to this. We've got our outer or inner ring from our hoop, and we've got our mold right over in here. So we're going to lay out a pattern of holes close to the outside of the ring, and then we're going to work towards the inside, getting lesser and lesser holes. And the reason for this is we want the plastic to start drawing towards the outside first. Essentially, this is a side profile or a cut right through here, and this is the outside of the hoop and our mold. So if the hole is here first and we got larger and more holes to the outside, it's going to draw the plastic as it's laying up here on top. It's going to draw it down right here first. And so it's going to suck it in and then work its way towards the center. The reason we want to do this is that it draws the plastic out and thins it out, as well as it's being stretched this way, it stops all that extra slack from the plastic being soft and malleable to create webbing. So as it gets closer to the mold, what will happen on the insides right in here as it's being drawn in, because the plastic's fairly soft, it'll actually suck together and create a web. And we don't want to do that. So if we draw it in from the outside and let the plastic lay down and work its way coming down around the mold this way, stretches the plastic out, thins it out, and that's to our advantage. So we're going to lay some holes here, more holes to the outside, and then a few more coming on to the inside, and then as we start getting closer to the mold, fewer and fewer. So on that pattern. Now right in the mold, because we've got some tight corners coming right on in here, what we want to do is create some holes really close right here in the corners to make sure that the vacuum draws it in. But they need to be smaller and fewer than on the outside, so it draws it in from the outside first. So the vacuum pattern should look similar to this. This is just sectional pied off, but you can see more holes towards the outside and fewer towards the inside, and then a couple in the key areas right into the inside cuts of this particular mold. Now, we can adjust this with just covering these holes up with tape as needed. Now, there's one other thing that we need to take into consideration, and that's essentially a fillet that's going to happen. When the plastic is drawn down, it's going to create a little bit of a fillet like this, because around the edges, it's not going to pull completely into the inside. It's going to be drawn down to the plastic, right like this, and then it's going to fill it up and then follow this mold right along here. So we're going to have this small, essentially fillet right in this corner. And that's the reason when we designed our part, we made it taller than necessary. One, we're going to have to do the trim line on it, but then two is because of this that's going to happen right in here. So our trim line on our mold where we actually need it, and we're going to be cutting it with the scissors, is something like that. Now we can adjust this by the temperature of the plastic, as well as after it's sucked down, we can actually even use our hair dryer to work around the outside of this to draw it down a little bit further. Problems is you get a blowout or where it overheats the plastic and it actually sucks through and creates a hole. Just make sure it's above the cut line. Now there's a couple things you can experiment with. If you need the plastic to become thinner and lighter on the particular mold itself, it's coming out a little bit too thick and a little bit too heavy, you can actually put something underneath the mold, between the mold and the top of the box, like a Lego or whatever you can do to raise this up. It'll cause the plastic to be drawn down and stretched and drawn out thinner as it comes down. Plus that'll move this down even lower, so it's above your trim line on the end result. So you can definitely play with that. Now another thing that you can do with this is drawing and creating a little bit thinner is what we call vacuum pegs. Big commercial machines have these actual little dowels that you can put in, and so as the plastic comes and it's drawn down over it, it hits this, and so it creates a web. It'll come down, up like this, and then down like this, and that draws the plastic out even thinner. One other thing it's going to do also is create webbing. If you were able to create some dowels in these areas, it causes the plastic to stretch out instead of the extra material wicking and sucking together. So if you got webbing issues where the plastic sucks together in these areas, you can always put something right here, tape down you know, a small Lego or whatever you want right in these corners right over here, which will cause the plastic to be drawn out thinner and suck into those corners without webbing and sticking together. So there's a little science, you just got to play with it. A lot of this can just be controlled with the temperature with the heat gun, since it is so small. You can basically not overheat the plastic, let it suck down, and then continue to heat it with the vacuum, and it'll continue to draw around the mold. Problem with this is, with this particular mode, is if you overheat the plastic while trying to draw it down, it's going to be very difficult to take the mold out of it when it's finished being done. But that's what we got the petroleum jelly for. It should be no issue at all. Let's go ahead and get our box poked up and move on to the next step. All right, so now I have all the holes cut into the top, and you can see I created a bit of a spiral pattern coming on to the inside with lesser and lesser holes, and a couple keyholes right next to the mold itself. So go ahead and pop the top off, and what we need to do is create a hole for the source vacuum. So what we're going to do is just grab your vacuum cleaner hose and just place it on there and trace around that. Go ahead and cut out that hole. We're going to just stick it into the hole, tape around it, put on the top. We're going to use double-sided sticky tape to tape the mold on down to the top, and then just go ahead and prep this with a little petroleum jelly, so that's our mold release on it. All right, so I have my box edges taped up. I got my vacuum cleaner hose poked right into the side and taped up as well. So all the airflow is going to be going straight down through these holes that we poked into it. Next, I'm going to take our 3D printed mold. I'm just going to use two-sided tape. And this is just going to stop it from shifting around as the vacuum is drawn over it. Okay, and it's stuck down. Next thing we're going to do is prep it with some petroleum jelly and a small paintbrush. It takes very little, and we're just going to basically paint over the mold. And of course, this will wash up with warm water when you're on your finished product before you do your cut line, and you'll be all set. Okay, so we are done with this part of it. Now what we need to do is prep our material and our hoop to do the vacuum forming, and we're moved on to the next step of actually making the product. Okay, next is prepping our material. Now you can pick up at any craft store this polystyrene type of material. It's available in white or clear. Now the white stuff is normally used to make architectural models. You cut them up with razor blades and make all kinds of different things, and it's available in different thicknesses. I'm using 0.4, so you want to start with a little bit thicker material, and then you can go thinner and thinner to get a smaller and lighter. But it takes a little more finesse with the vacuum forming so you don't suck a hole through the plastic itself. Gas makes a bunch of different sheets and different thicknesses as well as clear. If you're having difficulty finding polystyrene, you can always go to the framing department of any local craft store, and a lot of the plastic glass windows for framing is actually polystyrene, the clear stuff, so you can just go ahead and use this and paint it up. Extremely inexpensive for the amount of material that you have. So I've got a 0.4 millimeter piece of polystyrene. What I'm going to do is take the center hoop and place it down. I'm going to take the material that over it. I'm going to take the hoop and open it up as much as possible. I'm just going to basically I'm going to push it over that to prep the material. I'm just going to use a blow dryer or a heat gun to soften up the material. That'll allow me to push this down over the hoop, and then we'll have our prep material and we're ready to vacuum form. Okay, so the finished hoop is going to look like this. The reason we need this hoop is if we just put the plastic heated up directly over it, it would just bunch up like wrapping for food or saran wrap. And we don't want that. It'll bunch up, create a webbing. So what we want is as it's drawn down, it actually is forced to stretch from the material up and around things instead of drawing into the material. And so that is why we need the hoop. Now, one trick you can do when doing vacuum forming, if you were to put the hoop with the ridge so the plastic is drawn down first, like this, with the plastic on top, it'll be forced to stretch out, so it'll give you a thinner, lighter vacuum form. If you flip it over, it'll give you a thicker one because it has less distance to draw down before it starts moving towards the mold itself. So that's one thing you can play with different things to achieve different thicknesses on the material itself. Now all we're going to need to do is just take our heat gun blow dryer, and we're going to work this over it until the plastic is malleable. Now with polystyrene, what happens is normally when it becomes relaxed, you'll see it stretch out and get wavy, and then it'll actually tighten back up. When it tightens back up, then it's ready to vacuum form. We'll have our vacuum form box. All we're going to do is flip on the vacuum. We're going to take this and straight down. We're going to go straight down with it, and it's going to draw right up around our mold. And hopefully, first shot, we'll have a finished usable little mullet hood. Now, when you're moving this over this, it's critical that the plastic is evenly heated. If it's hotter on one side than the other, it's going to draw in on that side, and you're going to have a thick vacuum form and a thin vacuum form. Since this is so small, it's not really going to be critical on this, but just try to keep that moving and keeping it absolutely even on the heat, and then we're going to just rotate straight over and put it right down onto our vacuum. So the whole process from heating to vacuuming will probably take less than 20 seconds or so. Okay, my first attempt of the old shoebox method was semi-productive. Essentially, it started to vacuum down, but the problem is the vacuum, when it started to hit, collapsed the box down, and it allowed vacuum to suck in from the side, so it didn't have enough vacuum to pull it down around the mold, so we got a partial vacuum form. All I'm going to do is just take some cheap weather stripping foam, which you can buy at any hardware store. just run it around the outside, so when I put this down, that weather stripping is going to take up that concave of the cardboard box, and it'll create a better seal, and we'll be able to finish vacuum forming this down and around our mold. I'm going to go ahead and just try and reuse this one. If not, I'll just cut a new piece of sheet and put it in. We'll try it again. Okay, so a couple things on shoe boxes. You could definitely put some things on the inside to stop it from collapsing in a little bit, but this is more just a demo so you can understand vacuum forming. You can see we got an absolutely perfect mold on the first hit, so you can see we've got all of the angles, and it's nice and tight up and around the edges where our cut line is above that. So this is absolutely perfect all the way around. So all we're going to do is go ahead and pop out our mold, which should release because of the petroleum jelly, and there we go. So all I'm going to do is go ahead and just cut this out, give it a quick wash with some soap, and I'll just demonstrate the cut line. Okay, so I have our 3D printed mold that we just used to vacuum form, and you can see how it just sits up on top of that. But you can clearly see it's much taller than the original little hood that we designed for it, because it was designed to sit down below. If we take a look at these little legs, you can see how the tab comes down, and that's just to mimic the original one that catch onto these little body posts right in here. You can also see how it comes up along the back and cuts down and the front lip. Remember, I was saying in the vacuum forming we were going to have this fillet that would happen. You can see how it has a little bit of a curve. Let's see if we got a better one. Yeah, here we go. You can see right here how it curves, but it makes no difference because our cut line is above that. One thing you can do if you're having that is, after it's been vacuum formed, use your heat gun and blow right into the corner right in here, and it'll suck down further into there if you need it a little bit further down. But as you do that, that's going to really thin out this area. The other thing you can do is just underneath the mold, put something underneath here, stack a couple pennies or something so it's lifted up, and that'll cause this this little chamfer or fillet to move down even further and actually suck up underneath a little bit. So you'd have to come along here with a razor blade and cut it out, but you get a nice clean straight vertical edge with that. But like I said, when I designed this, I designed it with extra in mind so that's above the cut line. Now the other thing on the cut line is when I designed this mold, I didn't know where I wanted the cut line to be. What you can do in your mold is, once you've determined where the cut line is for it to come around and fit, you could actually go back in and transfer those curves to create a small divot in the mold. So as a vacuum formed, you can actually see in this, as I rotated it around, this was a fairly crude 3D print, 0.3 instead of 0.1 for a fine one, and you can actually see the little individual lines. You can see the resolution and how thin this plastic actually gets. So if you were to transfer it, 3D print a really high-res model for a mold, so you don't pick up these little lines, even though it's not even that noticeable on this. I'm pointing them out so you can see it. But if you were to take and transfer these curves to that mold along that, you could actually, on the vacuum form, have that cut line predetermined, so you're going to be able to just take some scissors and you don't have to measure it out yourself. Now, the one that I've already cut on there, you can see the cut line as it goes around the hood all the way around. And that's all we need to do to that on the vacuum forming out. So you just basically transfer these cut lines. In this case, what I ended up doing was putting the Mullet MOD VTX on there, and then I kept putting this down and trimming it up and trimming it down until it all nice and fat fit. and then just cut the center onto that. Now, in order to cut the real crazy angles without damaging it, always use a pair of like these are body cutting scissors designed for RC car bodies, but they're just like medical grade, real thin up here, a lot of control, and they've even got some that have a curve on it, which are really fantastic for getting in here and working around onto the cut line. But you get the idea of what you're able to do here with the vacuum form. All I need to do is put this down on top of the other one, follow along here, and transfer that cut line, and then come along and pop that one out, and then I have a second one. Now obviously there's a lot you can do with the different mold designs. I think if I were to go back and redo this, I would actually clean this little nubbin right here and create more of a teardrop as this came towards the rear. But I would love to see what you guys come up with. Since this is 3D printing and this whole print took about 15 minutes to print out, there's no reason you couldn't come in here and put a little fin, you couldn't do whatever you wanted. Come up here with googly eyes, make a little alien head or something like that. So it's more of a UFO. But there's a lot you can work with depending on what type of camera and everything you're doing underneath it. Even if you didn't want to do the Mullet mod with the antenna going up, there's no reason you couldn't actually create like a full bubble right here. Make it look like a UFO, paint up a little alien on this. Now since I used polystyrene, this white stuff takes marker extremely easily, so you can do a little permanent marker, a little bit of paint, and definitely make it your own. You can also paint it if you want with like an airbrush, but it's so small there's no reason you can't just use markers. But there you go. I'm going to go ahead and cut this one out and do a little markering up on it, and we'll take a look at the finish on it. Now also for this front hole, to cut this out, I actually was using just a rotary tool, a Dremel with a burring bit, and you can just poke in there and draw, you know, move it around. Another thing you can do is just use like a hot pin, you know, heat it up or a soldering iron to poke the holes into the side versus trying to cut those out. That works extremely well as well. Other than that, let's get cracking. Okay, there we go. Just went ahead and trimmed that out, cut out our hole, and it is just like our original one. What I'm going to do is go ahead and get a little creative with this one, and we'll see what the finish looks like. Alright, this is a quick comparison of the weight of the mullet cap versus the original stock ones. The stock ones are weighing about the same. I've got to weigh them 2 at a time because my gram scale, it won't even register 1 at itself, and you can see it's 0.8 there. You can see it in the lens. Okay, so you got to assume each one is 0.4. And here that is 1. That's right there. There we go. 0.8. So you can see it's negligible compared to the original cap there. Pretty much the exact same weight, but because of the structure of how the curves are on this, it makes it extremely strong. So it's going to definitely protect your camera. So definitely no reason not to do this mod, plus the cool factor as well. And there we go. The new Mullet mod cap we just made using a shoebox vacuum cleaner hair dryer. Alright, we're all finished, guys. Thanks for staying with us all the way through on this one. You can see the Mullet mod came out very awesome, especially now that I've used a little bit of marker to dress it up. And here's the stock one. Is it worth it? Up to you. It's about an evening's worth of your time, and it'll probably cost you less than your dinner to do this mod. It's fun for you and your friends. You could just, the 3D print and the shoebox method will definitely work for a few times until that box collapses in on itself. You could always make a more permanent vacuum box just using some MDF wood and fashioning up, or if you really got into it and had a bunch of different molds and wanted to make a bunch of different bodies, invest in a small hobby vacuum forming machine like this used for dental work. Guys, that's it. Like and subscribe. Please, if you make a mod or a mullet cap, send me a picture of it so I know to keep making these videos for you guys. As always, stay classy.